All right, now we're ready to start talking about karst topography, and another name for that is just cave formation. So the technical name is karst, but we're going to talk about how does a cave form. Well, first, a cave is going to form only in the right kinds of materials. So it has to be a kind of rock that is going to be easily dissolved. So can you think of any kinds of substances that would be dissolvable? Well, you could have salt. So salt is made of the mineral halite and it makes the rock salt. But the problem is that it's going to erode too quickly. You could also have another substance, like for example, gypsum. But again, you don't tend to have caves in the mineral gypsum. Okay, but you do have it in limestone and dolostone. So limestone is going to be made of calcium carbonate. So that is the mineral calcite, which is in the rock limestone. Okay, in dolostone, you have a combination of calcium and magnesium. And then it's still going to be carbonate. So what can happen is that water, when it percolates through the ground, can dissolve and break apart the calcium from the carbonate. And so then that's going to leave a hole where the calcite used to be. And we're going to call that hole a cave. Okay, what else do we need? So here's going to be the rock that our cave is going to be made out of. It's easily dissolvable. Okay, the next thing though that we're going to need is something to dissolve it. So you're obviously going to need water in order to do this. So in a dry climate, you're not going to have very much cave formation. You are going to have a lot of cave formation in a climate that does have a lot of rainfall. So you're going to need water, and then it needs to be acidic. So water is not going to be sufficient to be able to break up the calcium carbonate. So we need it for it to be just a little bit acidic, and we've already mentioned this before, but carbon dioxide, CO2, plus water, H2O, is going to make carbonic acid. So that's going to be H2CO3. So we've already talked about the chemistry of how this happens. So ordinary water, when you mix it with carbon dioxide, is going to make carbonic acid. Now there are a few caves that could be made with sulfuric acid. So instead of carbon dioxide, it would be sulfur dioxide. And so that tends to come out of volcanoes and also out of oil deposits. So sulfur dioxide plus water would make sulfuric acid. And for example, Carlsbad Caverns in New Mexico was formed this way through sulfuric acid eating through the limestone. But we're going to concentrate just on the carbonic acid thing. So now we've got the material that's going to become the cave. We've got the material that is going to dissolve the cave away. So that's going to be this carbonic acid stuff. And now we need for the water to get into the cave. So normally what you have is, here's the surface of the ground. And then covering the surface of the ground is going to be some kind of material that doesn't allow water to go through it. So we've already talked about clay as an example. So this is going to be called the cap rock. So this is going to be material that does not allow groundwater carrying the carbonic acid to get into the cave. And then underneath it is going to be where the cave is going to form. So this is where you have your limestone. Well, you still don't have a cave because the groundwater can't get through the cap rock in order to get to the limestone. So then the next thing that's going to happen is maybe you've got an earthquake or something that causes there to be a joint. So the ground shifts and it causes there to be a crack in this cap rock, which is going to allow groundwater to get through it into the limestone that's underneath it. And then it's going to start to erode away the limestone, beginning with any cracks. So if there's any fault lines that are running through this limestone, that's going to be the area that the water is going to go through, and it's going to start to enlarge that crack. It's going to start the hydrogen from the carbonic acid is going to start to act on the calcite, and it's going to break the calcium from the carbonate part. Both of those go into solution. They're dissolved in the groundwater and are carried somewhere else. And so what you're left with is going to be holes in the limestone, which we're going to call caves. Normally, cave formation is going to occur underwater. So let's say that the surface of the groundwater, the water table, is located right there, so that this hole is completely underwater. So most caves are going to form under the water table where it's completely liquid. But now what could happen is the ground could be lifted up, or the water table could drop. So when the water table, let's say the water table goes down to here, either as a result of dry conditions that cause the water table to drop, or maybe plate tectonics has caused the ground to be lifted up. So either way, now let's say that the water table is down here, and now this thing that used to be completely full of water is now a hole. Okay, so now this has dried out. So now you've got your cave. Now as groundwater keeps leaking into the cave system, it's going to start to drip into the cave. And then as it drips into the cave, the reverse of what we've just been talking about is going to happen. Instead of calcium carbonate being broken apart, what's going to happen is this groundwater is going to be carrying in calcium and carbonate dissolved, and it's going to go back together again and form travertine. So we don't call it calcium carbonate anymore. It is calcium carbonate, but we don't call it calcite. We're going to call it travertine. And travertine is going to start to develop on the ceilings. It's going to drip in. It's going to start to precipitate there on the floor. And we're going to start to develop deposits of travertine inside of our cave system. Now down here, you could still have more caves. So under this water line, under the water table, you can have another cave is beginning to be dissolved down here in this limestone. While this one up here, you're starting to deposit new material. In this cave down here, you're starting to erode material, dissolve material from down here. So eventually what you can end up with is caves on multiple levels. And so there are several examples of caves that do this. Here in Missouri, if you go to Silver City, you have Marvel Cave. And Marvel Cave is that cave that is pictured on the very first slide. That's how big the inside of Marvel Cave is. It's so big that there is I think it's a 4-story ladder that is on top of the rubble inside that cave. So the cathedral room is something like over 100 feet tall. And so that part of the cave began to form first, and then there are multiple levels to the cave where other passages have formed. All right, let's take a break, and when we come back, we'll talk about what features you will find inside of a cave.